Welcome to Python Packages with EJD. In this video, we'll be talking about geospatial packages for location-based data. All along we've been talking about Python packages, and they are actually a group of programs that help you to use Python better. And in different fields, you have different packages. In the last video, I think we considered Network X for graph analysis, right? Before that, we looked at OpenCV for computer vision. Before that, we looked at Hugging Face Transformers for natural language processing. And all of that we've looked at pandas previously, we've looked at NumPy, we've looked at SciPy, SymPy, and all of these things. So, but of course, you don't need to know everything. You just need to know what is necessary for your field, the library, the package that is necessary for your own field. So in this case, we're looking at geospatial packages for location-based data. So if you're into the geosciences, like you're a geologist, a geophysics, a geographer, a meteorologist, this may be useful for you. So introduction to geospatial analysis, right? So first of all, geospatial analysis involves the collection, visualization, and interpretation of data tied to geographic locations. So it may involve things like longitude and latitude and things like that. Then applications are very common in urban planning, environmental monitoring, transportation networks, epidemiology, business logistics, meteorology, like I said the other time, and so on, space physics, and all the rest. So then we have the Python ecosystem for geospatial analysis are quite there. Like Python has powerful libraries for handling geospatial data. So you have GeoPandas for geographical information system. You have Folium for interactive web mapping and Shapely for geometric objects. So GeoPandas, Folium, and Shapely. These are very nice Python libraries for handling geospatial data. Okay, so let's take them one after the other. Look at GeoPandas first of all. GeoPandas for Geographical Information System. So first of all, GeoPandas is an extension of Pandas. Interestingly, Pandas is that very popular library for data analysis, data manipulation, data cleaning, data handling, and all of that, right? So for data analysis, Pandas it is. So GeoPandas is an extension of Pandas, which adds support for spatial data types. So if you want to work with geospatial data, then GeoPandas it is for you. Then there are key objects there. So, in normal regular pandas, we have series and data frames. But in GeoPandas, you now have GeoSeries and GeoData frame. So GeoSeries holds geometric objects like points, lines, and polygons, while GeoData frame hold is like a data frame but with spatial geometric column, right? So the core features of this include reading and writing spatial data, using shapefiles, GeoJSON, KML, and KML. Then for spatial operations like buffering, overlay, joins, and dissolves. Then for coordinate reference system, CRS, for handling projections and transformations, and for visualization like quick mapping with dot plot and integration with matplotlib. So that's GeoPandas for you if you work with geographical information system. All right, so I have a bit of hints about it here for you as a demonstration. So it's quite elaborate because so here now you have to import GeoPandas as GPD, import OS within the operating system, then we import requests. I think I've introduced us to the idea of requests. I think it's useful for APIs, then API is API simply borders around different software communicating with themselves, right? Then you have imports. You also import zip file because you want to open a zip file. Then import short.il, import matplotlib.pyplot, of course, for visualization. So now, first of all, you define the file paths. So first of all, we have this URL, https://naturalair.s3 Amazon, AWS, and blah, blah, blah. And it's a zipped file, by the way. So the zip path, we want the countries.zip and then extract directory. So we want to extract it. So we have any underscore 110 underscore admin underscore 0 underscore countries like that. And then so this is, I think we did this under control flow where you do maybe some kind of exception handling, to help you to know, okay, you are trying different things. Whatever works, it will report to you at the end of the day. So if you are able to successfully do what you want to do, you get a report. And if you are not, you also get a report like that. So we have try. So download the zip file. So you print downloading shapefile. So this is to carry us along. So we have the zip file here. This is actually a real zip file. And then for the headers, you have user agent, Mozilla 5.0, Windows, blah, blah, blah. Then for response now, you have request.get URL stream. So, you are bringing request in here because, you know, we have some software, some devices communicating with themselves. And you have response.raise underscore for underscore status. So we say with open zip underscore path WV as F. So if we say for chunk in response, so chunk, I think we came across chunk when we're talking about Excel, that if you're dealing with a big file, it's better to deal with them in chunks. Then when it's all done, you now print downloaded the path you have downloaded and all of these things. Then you can then unzip the file. All right. I think we did this under how to import data to Google Colapse. So you can actually unzip a zipped file like that. So unzip the file. So you print extracting file. So when the file is being unzipped, so you now say with zip file, zip part r as zip underscore ref. Then you have zip ref dot extract all and all that. Then you can then load the shape file after extraction. So you have a shape path, OS path. You give the path because this is where the data is extracted to. So let me even see if you have something in the process of, okay, by the time I run that, I think I'll come and check. So far we don't have anything, but by the time all this is done, I suspect that some of these files will be at that will be under this files area. And then you load the shape file, right? Then you can filter for Africa. So if our focus is on Africa, then we have filter for Africa. We say Africa is world continent Africa. Then we say number of African continents, length Africa, and African countries rather. Then we plot. So print plotting Africa, then Africa dot plot in light blue. Edge color is black. You can change all of that. Then you can now say map of Africa, and then you have download. So if it fails, you also have that because we are doing exception handling from the beginning. That was what we started with try. Okay, I mean, having said all this, I just go ahead and run and okay, downloading shapefile, all these things. Yeah, I mean, it's faster than I would have imagined. So this is the African map now. So here it says downloading shapefile, downloaded countries, zip, extracting files, loading shapefile, number of African countries, 51. Well, actually, Africa has 54 or 55 countries, depending on whether Western Sahara should be regarded as a country or not, because Morocco is laying claim to that. Then you can plot and you have this now. Okay. So let's try for Asia. Since you're dealing with continents, so we try for Asia. So everywhere there's Africa, I'll just put Asia. I'll just replace with Asia. Okay, I think I can do control find, control F. Okay, will that work? Okay, let me just go ahead. Let me just do it step by step. Asia, interestingly, that's a very nice way to go. Asia. Oh, I said that's Asia. No, it's Asia. Asia. Okay. Number of Asian countries. Number of Asian countries. Then we have Asia. Asia. Where else? Asia. I think then this is still Asia. I think it's all done. Yeah, filter for now we are filtering for Asia. So Asia. So we run that now. So oh, it's still showing Africa. Why? Still showing Africa. Okay, something is wrong somewhere then. It's still showing Africa. If this doesn't work well, then I'll just forget about it. Filter for Asia. Okay. Still showing Asia, Africa. Okay, if that doesn't work, then let me just leave it the way it was. Control Z, 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 Z. Yeah, we're good. So it's Africa. Let's leave it that way. All right, so let's talk. So that we are done with GeoPandas, which is an extension of Pandas. Then we have Folium. for interactive maps. So if you want to interact, if you want to work with interactive maps, an interactive map is the kind of thing you get in Google Maps where you can, you can scroll the map and then you can go to a particular any continent you want to go to and all of that. That's an interactive map. So Folium is very good for that. So an overview. Folium is built on leaflet.js, which creates interactive maps for web display, and it integrates with Jupyter notebooks for easy embedding of maps. Easy embedding of maps happens like that. And of course, if it works in Jupyter notebook, then it can work in Google Colabs because Google Colabs is built on Jupyter notebooks. We have core features like base maps, that's multiple tile layers, OpenStreetMap, statement, terrain, Carto. Then we have markers and pop-ups, adding custom points with tooltips. Then we have choropleths, thematic maps based on data values. And we have overlays like heat maps, GeoJSON layers, and polygons. So a very good example, I will just demonstrate this. So here we have imagine that I want to create base map centered on Africa. So M is folium.map location. So I think this probably takes care of the whole of Africa or something like that. So it is focused on Africa, but it can still move around. You can still move to other continent. So you have zoom underscore stat equals 5. So add marker folium.marker. You have 9, this longitude and latitude. So pop up Abuja, Nigeria. So you're going to have a marker. You're going to have a pointer on Abuja, Nigeria. Then tooltip is click me. So you can click on it and then add to M. So at the end of the day, you can save, you can then say M save, and then you have map.html. So if you run this, of course, nothing shows up. If you want to visualize that map, so you just, M is what you have now. So you can run this M. So once you run this M, see what you get. So you have a graph. I mean, you have a world map that is pointing at Abuja like this. So so it's if you click it zooms in on Abuja. So if you want to zoom in, you can see, yeah, my hometown. I always like to see my hometown on the map from somewhere in Lagos State. Yeah, so this is Lagos, right? So I want to zoom in. It's at the coastal area, Badagry. Where's Badagry now? Oh, where is it? Okay, this is Igbo. Okay, I think I've zoomed too much. I want to be able to follow it gradually. Yeah. So satellites, yeah. If I'm seeing satellites, I'm getting close to home. Ikotun, Agbara. Yeah. Yes, this is Badagry right here. Yes. So I was born somewhere around here. So yeah. So you can see how Folio is really cool. So you can see the whole of the world at once, and then you can zoom in to anywhere. So like right now, we are here in Sendai City like this. So this is so cool. Yeah. So Folium is that useful, very helpful. So anything you are interested in seeing. So for interactive maps like that. All right. So let me let's go back to where we were. It's like I'm too far away from home. What can I do here? Oops. This is serious. Okay. What can I do? Hmm. Wow, have I gone away so much? Okay, I think I can reopen this. So like reloading that file if possible. Okay, if that doesn't work, then I can close and then open Collab again. Yeah, so I work with Geospatial packages. Oh, that's serious. Okay, yeah, we are back here. So I'll just need to go over these things again, run this. Okay, it's like the session is still uneven. Then we are on Folium. Okay, this is it right here. So pretty interactive. So if you want to zoom in on say Lagos or something, so what we just need to do is put the long and lat, we say pop up Lagos, then just so it will click. So we had Nigeria before. So Lagos, I mean, this is looking like Port Novo, but it's actually Lagos because Port Novo and Lagos are pretty close. If you shrink the, so this is actually zoomed in on Lagos like that. Okay. Yeah. So now, so we've seen GeoPandas, we've seen Folium, Folium for interactive maps. Then we have also um, we have Shapely for geometric objects. So Shapely is more of a geometric thing. It doesn't necessarily bother about visualizations. So overview for Shapely, right? So we have geometric engine. It defines and manipulates geometric shapes, right? So Shapely defines and manipulates geometric shapes. It works with GeoPandas. So it is the core library behind geometric computations. Then the core features we have geometric objects like points, line strings, polygons, multi-polygons. Like for people, land surveyors or architects and people like that can find this very useful, or building technologists. So spatial relationships. You can talk about intersects, contains, touches, overlaps. Then geometric operations like buffering, union, difference, convex hull. Measurements like distance, area, length, and centroid. If you need to do some kind of setting out to construct a bridge to build a house and things like that. All right, so we have a very good example here. So from Shapely.geometry, you can import point and polygon. So you want to define a point. So you say P is 0.23, X and Y axis now. So 0.2, comma 3, you define that point. Say you may also want to define a polygon. So to define a polygon, you have poly is polygon 00404404. So this is for sure like a quadrilateral, I believe. Yeah, yeah. This is like a quadrilateral, maybe like a square or something like that. So then you can now print points within polygon, P within polygon like that, and then polygon dot area. So if you run this, then it just tells you polygon, points within polygon, it says true. So do we have, is this 2, 3 within this polygon? In fact, let's even try to do some visualization. I didn't plan to visualize before, but I think it would be nice to see some visualization. So visualize. It's not meant to visualize originally, but I think with the help of say maybe matplotlib now, we can get visualizations from Shapely. So the power of AI will come to play. Oh, it's display map. That's not what we want. No, that's not what we want. Okay, that's not what we want. We have this is already sorted, so we don't worry about this. Yeah, this is already done. This is all we want to visualize. Yeah. Uh, okay, why is it becoming like this? Let me start a fresh new chat. This, then let me just say display. 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 Okay. Let me just say display. This doesn't work, I'll just move on. So the polygon area is 16 because of course from the all the marks 0, 4, 0, 0. Oh, okay. Cancel. We don't want that. We've done all of this before, so no worries. Yeah, so I think I just want to leave this alone. So, but now we know the area, we know that 2, 3 is within that place. So I think I just want to move on with this now. Or should I try one more time? Never say die. Available AI features. Aha, good. This is what I was looking for. Okay. So it can explain the code to you if you want. And then, but ultimately, I just want it to display. Yeah. So it says all this. Uh, so I just wanted to visualize. So it may need to bring in matplotlib and everything so that we can see what, yeah, great. So it has brought in matplotlib exactly. So I run this now, and then we can see that the shape, that shape 2.3 is within the region defined as 0, 0. This is 0, 0 right here. We have 0, 4, 0. This is 4, 0 right here. Then we have 4, 4. This is 4, 4 around here. And this is 0, 4 up here, right? So yeah, that's the visualization, shapely points and polygon. So we have that. I think that's nice. Okay, so integrated workflow now. Use Shapely if you want to build and manipulate geometries. Use GeoPandas if you want to store geometries in data frames, run spatial joints, and project data. Use Folium if you want to visualize results interactively on web maps. Then applications and projects. If maybe you want to map COVID-19 hotspots with Folium heat maps. You want to analyze deforestation patterns using GeoPandas overlays. You want to calculate proximity of schools to industrial zones with Shapely. Then you want to build a web-based dashboard with Folium for urban traffic monitoring. So these are some applications of these three. So for geospatial packages, you have GeoPandas, you have Folium, and you have Shapely. Very useful tools if you are into the geosciences. All right. So with this, we come to the very end of this video. Let me know how helpful this is for you. And if you want to know if you can tell me your field in the comment section. And if you're interested in knowing if there's a Python package for your field, I'll tell you if I've already done a video on it or if I need to go and make a video on it. Feel free to let me know either on Facebook or on YouTube. If you have subscribed already, thank you so much. If you haven't subscribed, of course, you'll be missing a lot. So just go ahead and subscribe right now. And don't forget to hit the notification bell so you can always get alerted each time a new video is released. Having done that, we want to take it a step further. You can click on join and you become a member of the channel with some special privileges. Ultimately, don't forget to comment, like, and share so that more people can have access to the great content I have going on here. Till I come your way again, keep doing Python right. Bye.